Hi everyone, it's a beautiful day to learn, so let's study network architecture. So networks must support a wide range of applications and services, as well as operate over many different types of cables and devices that make up the physical infrastructure. The term network architecture in this context, it refers to the technologies that support the infrastructure and the program services and rules or protocols that moves these messages across a network. So in this lesson, we are going to understand the need for a fault-tolerant network, understand the need of scalable network, we will talk about the quality of service, and we know what is the importance of security in computer networks. As networks evolve, we are discovering that there are four basic characteristics that the underlying architectures need to address in order to meet the user expectations. Number one, we have fault tolerance, scalability, the QoS, and security. So let's take a look at it one by one. When we talk about fault tolerance, we design the system such that we need to include unforeseen problems like power failure, network interruption, computer backdown, and many things that might occur during the operation of these networks. So the expectation is that the internet is always available to millions of users who rely on it. No? This requires a network architecture that is built to be fault tolerant. So when we say fault tolerant, it should continue to function normally even if some components fail, and it should also ensure that there is no loss of service. Okay. Let's take a look at this simple diagram. What happens if one of the components will back down? Let's say the switch in the middle. So if that particular switch breaks down, or as simple as the plug was broken and there was no power in it, then definitely all the devices that are connected in it will not be able to access the network or the internet. Imagine if that is internet and we rely on one critical device or critical component. And if that component bugs down, then everything will be at a stall, and which is not good, right? So when we have fault tolerance, again, we make sure that the network should continue to function, even if some components will fail. So looking at the next slide, here is an example of a network which have redundant devices in it. You see the blue circle, that is called a router. And the square ones, the square ones, those are the switches. So from one point to another point, if one path is broken, let's say a wire was beaten by a rat and there is no connection physically, then how is that? So it's very difficult to figure out that a cable was beaten, you know, you know, disconnected because of rat, probably, or something that was unplugged unintentionally. So with this kind of network, you should be able to communicate with other devices by providing redundant path. Okay? So if one of these will fail, let's say for example, this one will fail, there is still a path, as you can see from the lines that connects this diagram. That is fault tolerance. But remember, it depends on the kind of network that you are designing. If this is just a simple home network, well, it's not really practical that you have two routers in your house or two switches just to make sure that when you are playing your favorite game, it will not disconnect because your little brother just unplugged one of the um, switches or routers. Scalability simply means the ability to grow and react to future changes. There are thousands of new users and service providers connect to the internet each week. In order for the internet to support this rapid amount of growth, it must be scalable. Scalable, it should be able to grow. It should be able to grow without affecting the performance of the network. Like for example, if you're going to plug in one computer, there is no need for you to shut down the entire network. Just plug the computer and it goes. So similarly, when you come to school or when you come to a place where there is Wi-Fi, you just simply connect to the Wi-Fi and the internet or the network grows without really affecting the performance nor disrupting the operation of the network. Okay, so looking at this, you could see that from the diagram that we have here, when you want to plug something, you should be able to add that particular device without disrupting the network. Even if the internet architecture is currently highly scalable, it may not always be able to keep up with the current pace of user demand. So we have thousands of users joining the internet or connecting to the internet maybe on a daily basis. Next, quality of service. The quality of service is an ever-increasing requirement of networks today. So when you have new applications that are available, such as voice and live video transmissions, Zoom, Gmeet, YouTube, of course, you expect the users to have a quality service, meaning the videos are working seamlessly, no buffering. So if you're going to provide a service like a gaming service or I don't know, Dota maybe, I don't know, make sure that the users will have a quality experience when they do the gaming. So it's about prioritizing which. Looking at this diagram, you could see that the messages, a little bit color coded here, some of them are classified as high priority, the others are medium priority, and we have also low priority. So it depends. If it's a voice over IP, then probably we need it to be high priority because it's a real time thing. It needs to have an update. It needs to have a bigger bandwidth as opposed to using your email. So that the experience that you will get when you are doing a teleconferencing, a video conferencing is uh, very good. It's a seamless experience. When you prioritize queuing of messages so that you could provide quality of service, there should be priority decisions for an organization that might include categorizing the services in terms of its being time-sensitive communication or non-time sensitive communication. Like for example, YouTube. This is a time-sensitive communication. Zoom, Meet, these are all time-sensitive communication. Meaning, a 1 second delay for these services really affects the quality of that service. So you just imagine we are doing this Gmeet and then you have a choppy voice, or you have an ever disconnecting experience, and that is not good. Why provide the service if it's not quality at all? On the other hand, you have Gmail, you have accessing a website. This could be a non-time sensitive communication. So you would like to decrease the priority of this kind of service. In the first place, it's not time sensitive. So if it's delayed by 2 seconds or 3 seconds, no, it doesn't really matter. It does not hurt. You could not really notice the difference between as opposed to having that in a video call. Okay, that's how you allocate. We could also give high importance to organizational processes or services. So You have your enrollment system, you have your access in our school. So if you want that that students would be able to enroll quickly, then that service should be given priority. You should be able to increase the bandwidth allocated to that particular service. Okay? So just to summarize, when you provide a quality of service, it's prioritizing. Prioritizing in terms of the need of the service. A YouTube service, a Zoom service, a Meet or Google Meet service requires higher bandwidth. So you have to allocate more resources to this. Otherwise, you have a YouTube that always buffers and it's a useless service. On the other hand, you know that emails, reading the web pages, this does not require large bandwidth. And also, you might want to decrease priority to undesirable communication. Like for example, you would like to block unwanted activity like peer-to-peer file sharing with torrent. Pag may nagda-download ng malaki, you should be able to decrease the priority so that the bandwidth is not concentrated on that particular service. Last is security, which is the very important aspect of networks today. Security simply means the ability to prevent unauthorized disclosure. So you don't want other people to be accessing your network, the data, your personal profiles, theft of information. So if you have trade secrets and a lot of things, even credit card numbers, phone numbers, when they are given to people, or even email address, it becomes vulnerable to spamming. They send you a lot of marketing something, and it becomes really annoying and unacceptable on the part of a legitimate user. The denial of service or DOS. In latter chapters or in later chapters, we will be discussing this. No? So what is denial of service? Let's say, for example, a legitimate service is HTTP, port number 80. That is a service. So when you open the browser and type something, you are using port number 80. What if an application keeps on pinging, keeps on requesting the service port number 80? Then legitimate users will not be able to use that service anymore because there is one application that constantly bombarding you with requests continuously because it's programmed. The legitimate user who tries to access your service cannot do so because it's already busy servicing that particular malicious attack. So that's a very important aspect of security. And security simply means the ability to provide confidence in users. If I am going to purchase something in Lazada, then you have to provide security, or and I'm sorry, you have to provide the confidence of the user that whatever information, whatever purchases, whatever financial things that the user will input in that particular website of yours, it will not be compromised. It will not be stolen or used for other purposes. Imagine if you are going to make use of an online banking, which is common right now. You have to provide that confidence to the user and make sure that the service you are providing is fully secure. The integrity. Okay? So integrity meaning data integrity. It means having the assurance that the information has not been altered in transmission. Okay? When the message is requested from one point to another, it has to travel to many routers, and those routers are accessible by their owners. And there are sniffing tools that are available out there that can be used by hackers. And you have to make sure that that message traveling across the internet should be able to withstand this kind of attack, probably encrypting to the highest level. Okay, so integrity. And last is the availability. You would like to ensure that the service is available. You would like to ensure that your service is available. It means it's having the assurance of timely and reliable access to data services for authorized users. Baka naman, because you are trying to secure it and such that the legitimate users will not be able to access anymore your service. So, building a fully redundant network infrastructure with a few single points of failure can also reduce the impact of these threats. One basic level of security is to simply ask for a login, username and password. So at one point before the user could access the devices below, you should be able to ask the user for a authentication. But that's very basic. That is just one level. You could also provide a firewall. You should provide encryption mechanism and many more that should secure the entire network. And to summarize, we learned that there are fundamental expectations to the network or the internet in general. Fault tolerance, there should be redundancy, scalability, the ability to grow, quality of service. You have to provide a quality experience to your users for every service that you provide, and scalability. No, I'm sorry. And security, making sure that users have confidence in using your network and providing them integrity of the app. That's it for network architecture, and see you again in next video.